Have a great day. This is page number 37. In here we can see first the diagram. Field erected spreaded stoker boiler unit. It burns a wide variety of coal and solid waste in addition to gas and liquid fuels. Unit capacity is 115 ton per hour. Here we can see the plenum chamber in the bottom of the diagram, and FD fan also there, and ash hopper is also there. Coal is fed to the left side bottom of the boiler, and here the burners for firing oil or gas. This is the burner, and it is going to flue gas is going to right side of the boiler. Fly ash re-injection is also available in the middle of the boiler, and flue gas going through the bare tube economizer and bypass duct, and after the flue gas is going to right side bottom of the boiler. Bypass duct also available. The first question, what are the usual operating temperatures, pressures and capacities of field erected boilers? Answer, steam generally capacity 20 ton per hour to 180 ton per hour. Operating temperature 450 to 500 degrees Celsius. Operating steam pressure is 61 to 102 atmospheric pressure. And next question, why is close control of furnace exit gas temperature necessary in the case of reuse fired boilers? Once again, why is close control of furnace exit gas temperature necessary in the case of refuse fired boilers? Answer, the temperature monitoring and control is imperative to minimize lag and fly ash deposition. Next question, what are the types of fluidized bed boilers are used in industrial unit? Answer, bubbling bed boilers, circulating fluidized bed boilers are the fluidized bed units mostly used to meet the demand of industries. They are all water tube boilers. The question, what are the basic design feature for bubbling bed steam generators? Answer, A. New natural or forced circulation water tube fluidized bed steam generator designs are used for industrial and utility applications. B. Combustor can be single or multiple cell partitioned by water walls, shown in figure. Is the Foster Wheeler bubbling bed boiler. So here we can see the Foster Wheeler Corpan NJ08809-4000 USA. This is the bubbling bed boiler. Source SP87-4 or 95. Tech paper versus FW. In here we can see the overbed fuel feed system in the left side of the boiler, and water cooled grid and planum is bottom of the boiler, and the boiler blank is available in the middle of the boiler, and superheater also available in the bottom of the boiler. The continuation of answer of the question, what are the basic design features of bubbling bed boiler steam generation? Answer is once again natural of forced circulation water tube fluidized bed steam generator designs are used for industrial and utility applications. B. Combustor can be single or multiple cell partitioned by water walls, shown in figure. So the next answer C is air plenum chamber installed beneath each cell supplies the fluidizing air that also supplies oxygen to sustain combustion. C. The part and parcel of the boiler circuitry is a water cooled air distributor that includes directional air nozzle which assist in directly any large ash or non-combustible tramp materials towards the bed drain. A fly ash injection system is normally embodied to optimize the unit's combustion efficiency by recycling unburned particles to the fluidized bed. Fuel is typically fed to the boiler using mechanical spreaders to distribute the fuel all over the bed surfaces. Last one, limestone is used for sulfur dioxide emission control. It is either introduced as the primary bed material or fed with the fuel as needed. So we can already see in the picture. So the next question, how are the water was arranged in the bubbling bed boiler? The water wall tubes are oriented either horizontally or vertically within the bed. The next question, what is the chief advantages of vertically laid water wall tubes over laid water wall tubes? Answer is horizontal steam generating tubes are associated with more erosion problem than the tubes disposed vertically. Question, what measures are adopted to minimize erosion of in-bed tubes? Answer, tubes are fitted with studs or fins, coated with protective metal coating, chromized to combat erosion. Question, thermal spray coating times, CFB erosion. How has this been made possible? Answer, with the advent of new spray process such as electrical arc wire and high velocity oxygen fuel HVOF and improved coating materials, it has been possible to battle out corrosion in the most aggressive environment of CFB. Question, what are the advantages of thermal spray coating? Answer, thermal spray coatings have demonstrated their ability to increase component life, reduce forced outage rates, extend the interval between scheduled shutdown. In CFBs, they have following advantages: negligible loss of heat transfer, and during spraying process, no heat is applied to the tubing. Tube temperature remains below 395 degree Kelvin. Application cost is 30 to 40% lower. Application time is significantly less. Wide choice of coating materials. These are the advantages of thermal spray coating. Question, cite two examples of coating materials. Answer, iron iron based alloy containing 30% of chromium, low carbon steel similar to chemistry and hardness to the material in the existing weld overlay. Again the question, cite two examples of coating materials. One is iron based alloy containing 30% of chromium, low carbon steel similar to chemistry and hardness to the material in the existing weld overlay. Question, how is this thermal spray coating applied? Answer, one widely used technique is the electric arc wire process. It is the easiest spray process to use. Electrical arc wire is portable and involves little in boiler equipment. It uses compressed air instead of inert or combustible gases. It is quieter and logs higher material deposition rate. Quieter and logs higher material deposition rate than other spray process. Question, what parameters are manipulated to control the steaming rate? Answer, bed height, bed temperature, solid inventory, superficial gas velocity. The next question, what are the basic characteristics of circulating fluidized bed boilers? Answer, they generally do not have in-bed tubes. They use hot solids separation device, cyclones, to minimize erosion of heat absorption surface. Three, many CFBs have an external heat exchanger. Some CFBs do not have external heat exchanger. The superheater is placed in the dense phase flow at the top of the furnace or in the convective shaft downstream of the particle separator. What is EHE? It is means EHE, external heat exchange. So it is the refractory lined box into which are arranged tubes bundles. The next question, what is the purpose of fitting an EHE? Answer, it cools the solid returning from cyclone separator. Changes in load condition and fuel properties alter the heat absorption rate in the furnace. The EHE helps to compensate for variations in the rate of heat absorption. Heat transfer in the EHE increases when absorption in the combustor decreases, and vice versa. Heat transfer in the EHE increases when absorption in the combustor is decreases, and vice versa. Remaining we will see the next video. Thank you. And this is the page number 40.